Hello student. So today next question is the rate constant for the decomposition of N2O5 at various temperature is given below. Here temperature is given in Celsius, that is 0, 20, 40, 60, 80, and rate constant is given in the form of 10 to the power 5 multiplied by K per second, that is this value is given 0.0787, 1.70, 25.7 in the form of this value. So what's the question is, draw a graph between ln k and 1 by t and calculate the value of A and EA, that is energy of activation. Predict the rate constant at 30 degrees Celsius and 50 degrees Celsius. So you have to calculate, first you have to draw graph between ln k and 1 by t, and then we calculate the value of A and EA and rate constant at this temperature 30 degree and 50 degrees Celsius. So first of all we have to draw a graph between ln k and 1 by t. So here temperature is given, that is in Celsius. So you should remember this, that temperature given in 0 degree, that is in Celsius. So when you have to draw a graph between this, you have to convert this in Kelvin first, because temperature is always represented in the form of Kelvin. So first you have to convert this into Kelvin. So how to convert? Temperature is given in Celsius, so simply you have to add 273 Kelvin. So this will become 273. You have to simply add this 273 Kelvin to each temperature. Now next become 293. And next temperature will become 40 plus 273, that is 7, 4, 11, 313 Kelvin. You have to name this, that is T1, T2, T3, T4, that is 60 plus 273, that will equal to 333 Kelvin. And last temperature is 80 plus 273, that will be equal to 353 Kelvin. So these are all the temperature we have calculated in Kelvin. Now next, that is the rate constant value, and here rate constant value is represented as 10 power 5 multiplied by K per second. This is rate constant value of 0.0787. Now if we move this to right side, it will become, rate constant value will become 0.0787 multiplied by 10 to the power minus 5. That will be the rate constant value. Now this value is given in log K value, and we have to calculate it in ln k value. So what is the relation between log k and ln k? That is log k is equal to log k multiply by 2.303 is equal to ln k. So this is how you will calculate ln k value. Simply you have to multiply by 2.303. So we get ln k value. Now next, first of all, here we calculate temperature in Kelvin. So we have to calculate temperature in, here temperature is 1 by T, that is means inverse of the value. So here T1 value is 273 Kelvin. So how much will be there after inversing it? That is 1 by 273 value, that will equal to, so after inversing this will become 1 by 273, that is equal to 0.0366 00. Here one more 0 is there. Now this is the value of 1 by T. Now second temperature, that is 1 by 293, that will equal to now 1 by 293, that will equal to 0.003 13. Now next 313 Kelvin inverse is equal to 0.00319. Now next value will become 0.003003, and this value will become 0.00283. Now this is the inverse temperature value, and listen, you have to draw a graph. So you have to convert into significant figure, so that this will become located on the graph paper. So how to convert this? Simply you have to put all the decimal at one place. So that will become equal to 3.66 multiply by 10 to the power minus 3. Sorry, 3. And here this will become equal to 3.413 multiply by 10 to the power 3. Similarly, all this 3.19 multiply by 10 to the power 3, and here this also become 3.00 10 to the power 3, and this value will become 2.83. Now you can locate it in the graph, all this value. Now next is the rate constant. You have to convert this in the natural logarithm. at the base E. So you have to multiply this simply to 2.303 1 by 1. Now we calculate this. Log k is equal to 0.0787 multiplied by 10 to the power minus 5. Now first we convert this into significant figure. So this will become k is equal to 7.87 multiplied by 10 to the power minus 7. So this is log k value. Now we have to calculate this log 7.87 value multiply by 10 to the power minus 7. So we know that this power become equal to 10 to the power minus 7 will become equal to minus 7 log 10, that is 1, plus log 7.87 value, that will become equal to 0.896. Now after calculating this will become minus 6.104, and we know that log k multiplied by 2.303 is equal to natural logarithm. So for converting this log k, we multiply by 2.303, then it will become ln k value, 2.303. Now ln k value will become minus 14.0575. Now similarly we calculate other one. Now next log k value will this 1.70 multiply by 10 to the power minus 5. 1.70 multiply by 10 to the power minus 5. Again it will become minus 5 log 10, that is 1, plus 0.2304. Now this will become minus 4.7696. This is log value. Now again we multiply by 2.303, that will become equal to minus 10.98. Similarly we calculate all this log k value of 25.7, that will become equal to 2.57 multiplied by 10 to the power minus 4, and this value will become minus 4 plus 0.4099 is equal to minus 3.5901 multiplied by 2.303, that will equal to minus 8.2680. Similarly we calculate the rest of two log value, that is 1.78 multiplied by 10 to the power minus 7 and 2.14 multiplied by 10 to the power minus 6. Similarly we calculate log 1.78 multiplied by 10 to the power minus 3, and here log 2.14 multiplied by 10 to the power minus 3. Similarly we calculate all this value. Now after rearranging, first you have to draw the graph between ln k and 1 by t. So first you will write all the value at one side so that you can easily make the graph. Now this is the whole table of 1 by t temperature and ln k value. So this is the initial and final value. So you have to represent the graph between 1 by t and ln k. Here ln k is in negative sign. So in graph we know that so this is the representation of 4 quadrant. Here this is plus y minus x plus x. This is how you represent on the graph. Here we take 1 by t value and here we take ln k value and the line will goes like this. So negative line is represented. So we know that after changing the position to upward there is no any change in the graph. Now this is how you will locate all the point on the graph. Here now we will take from table the various point, that is 1 by t and ln k value. Here 1 by t is here. So at 3.66 value ln k value is minus 14.057. So here we locate this 14 value, that is here, and at 3.41 ln k value is minus 10.98, 3.19, sorry 3.41. Here 3.41 ln k value is 10.98. So here you look at now at 3.19. Now next point is at 3.19 ln k value is 8.26. So 3.19 ln k value is 8.26 here. Now at 3 ln k value is minus 6.352. 3 ln k value is minus 6.352. Now at temperature, inverse temperature 2.83 ln k value is minus 3.844. 3.844. Now this is how you will locate all the point on the graph, and after joining this will become, now after joining this a straight line is found. So a straight line graph is obtained, and next what we have to do, calculate the value of A and EA. Now next we have calculate the value of A. So how to calculate the value of A? we will write the Arrhenius equation. That is, Arrhenius equation is K is equal to A E minus EA by RT. This is the Arrhenius equation. Now we write in the form of ln K value, that is ln K is equal to ln A minus EA by R multiply by 1 by T. Why we write in the form of Arrhenius equation? So that because we draw the graph between this form, that is 1 by T, and ln K value. Now we will write in the form of slope equation, that is y is equal to mx plus c. This is the straight line equation. Here slope is the minus EA by R, minus EA by R, and we have to find out the slope value. So slope value will be, that is equal to, now slope value is, how to calculate, y2 minus y1 upon x2 minus x1. Here from the graph we take y2 and x1 value. Now here we take slope value y2 minus y1, that is from the table. Here we take y2 is located on y axis, that is ln K. So y2 we take this, and y1 we take 10.98, and x2 we take 3.66, and x1 that is 3.41. Why? Because at x-axis temperature, inverse temperature is located, and at y-axis ln K value is located. So we take this value, that is minus 14.057 minus minus 14.057 minus 10.984 as it is given, and here x2 minus x1 value is 3.66 and 3.41. Again here x2 we take 3.66 minus 3.41. So from this we calculate the slope. Now after calculating this will become, now this calculated we get minus 3.073 divided by 0.25. So the value will become minus 12.3. And this is the slope value, that is slope value is minus EA by R. Now this will become minus EA is equal to minus 12.3 multiply by R, that is gas constant 8.314. After calculating it will become 102.2622 joule per mole. So this is the EA value. Now we have to find out the, here minus minus become cancel each other. So value will be positive. So EA value is 102.26 joule per mole. Now next we have to calculate the A value. So how to calculate this? Now we calculate the ln A value, because we have to calculate A value, and from this equation we calculate ln A value, that is ln K is equal to ln A minus EA by R multiply by 1 by T. So putting this value here, we know that EA value is calculated and R value we know, and temperature we take initial, that is 273 Kelvin, and ln K value is initial, that is minus 14.05. So after putting this value in equation, we get ln A is equal to ln K minus EA by RT. So ln K value is minus 14.05 plus EA value is 102.26 that we have calculated upon 8.314 gas constant multiply by initial, that is 273 Kelvin temperature. So ln A will become minus 14.05 plus 0.0450, and ln A value will become minus 14.005. So this is ln A value, and you have to calculate the ln A value. This is ln A value, and we have to calculate in the log form. So formula is ln A is equal to 2.303 log A. So from log A we find out the A value. That's why we convert it into log A value. So log A will become 2.303 divided by ln A value. Here mistake is, here ln A by 2.303. That is ln A by 2.303. So that will become minus 14.005 divided by 2.303. So log A value will be minus 6.081. Lots of calculation is there. What will I do? Because in question what they said, you have to calculate this in this way. No any other option is there. Now log A value is minus 6.081. So we have to take anti-log of minus 6.081. So after calculating this antilog of minus 6.081. Now antilog of, after calculating minus 6.081, this will become 0.919 multiply by 10 to the power minus 7. And please do watch the log and anti-log table if you do not know, because without the log calculation you cannot do single step of the question. And video is given in the description box, so please watch this. So anti-log become equal to 8.299 multiplied by 10 to the power minus 7 per second. So this is how you will calculate the A value. Next you have to calculate the rate constant value at temperature this 30 degree and 50 degree. Now again we take this temperature degree Celsius into Kelvin. First we convert this. Now adding 273 to 30 degree, this will become 303, and 273 to 50 degree Celsius, this will become 323. Now because you have to calculate from the graph, so here temperature in degree Celsius, that is 30 degree Celsius and 50 degree Celsius. Now in Kelvin temperature, this will become 303 and 323, and inverse of temperature will become equal to 0.00330, and here 0.00309. Again in significant figure it will become equal to 3.30 and 3.09, and here ln k value will become. Now we have to calculate ln k value from the graph. So first we take the graph here at 3.30, that is this point, and at 3.09, that is this point. Now we locate the point here at 3.30. We draw the line 3.30. Now after locating this all the 2 points, we get the value. ln k value is between 9 and 10, that is 9.4 we assume, and here at 3.09 we take ln k value minus 7 from the graph we calculated. So ln k value become equal to minus 9.4, and here minus 7. This is the ln k value from the graph we calculated. Here ln k value is 7.3, because here graph 7 is upper side, and here after some point line is represented. Here upper point is 7, and after some point the line is represented, so we take logs ln 7.3 value here. Now next, from ln k we have to calculate the k value. So how to calculate this? Again we calculate the k value from ln k as we have done in previously by calculating ln k to log k and taking the log value. We calculate the k value. So here how to calculate ln k value? Now we know that ln k is equal to 2.303 multiply by log k as we have read. So log k value is calculated by ln k by 2.303. So at 30 degrees Celsius, at temperature 30 degrees Celsius, log k is equal to minus 9.4 by 2.303 is equal to minus 4.082. Now k is equal to, we take antilog because minus value is given minus 4.082 and we know minus sign is, we take antilog. So here after taking antilog of minus 4.082, this will become antilog 0.918 multiply by 10 to the power minus 5. After solving, the k value will become 8.279 multiply by 10 to the power minus 5 per second at temperature 30 degrees Celsius. Now next we calculate log k value at temperature 50 degrees Celsius. Now at temperature 50 degrees Celsius, log k is equal to minus 7.3 divided by 2.303 because at 50 degrees Celsius ln k value is minus 7.3. So here we take log k value is minus 3.17 and minus 3.17 we take antilog of minus 3.17. So after this calculating this, we take antilog k minus 0.83 multiply by 10 to the power minus 4. So k value is equal to 6.76 multiply by 10 to the power minus 4 per second. So this is the k value at 50 degrees Celsius. So both k we calculated. Now this both rate constant value is calculated. Now if we write in terms of k into 10 to the power 5, then both rate constant will become, this rate constant will become 8.27 per second and write down at 30 degrees Celsius and at 50 degrees Celsius, here this will become 67.6 multiply by 10 to the power minus 4. Now this rate constant will become 6.76 multiplied by 10 to the power minus 4 in terms of 10 to the power 5. This will become 67.6. So second rate constant will become 67.6 at 50 degrees Celsius. So this is how you will calculate it. And what about graph? Here graph is in the negative form, and if we invert this in the form of this, then also a straight line is found. Suppose we take 1 by t multiply by 10 to the power 3 on x-axis, and at y-axis ln k this goes downward, then again straight line is obtained. So this is how you will find out all the question calculation, and this is a lengthy question, no doubt, but your concept will clear from this video. And if you have any query regarding the video, you can ask me in the comment section. Do like and share with your friends, and thank you for watching, and keep learning.